So in this session on signals and systems, we are going to study a rule called as the pair sum rule in the calculation of convolution. So let us start. So pair sum rule. Now why this is useful? So let us reconstruct our method of finding the convolution. So you have to slide the second function, you invert the second function, and then you slide it past the first function. And then you first take it to the extreme left and then slide it to the right until the overlap occurs. And when the overlap occurs, what you need to find out is the expression of the product of these two signals and the limits of integration. These are the two things that you need to find out. Now, in simple cases, the inspection of the graph will enable you to find the expression for the product and also limits of integration. But it is not always easy, and there are times when it will be rather complex, and just by inspection it may not be very easy to find the expressions as well as the limits of integration. So if you have some rule, so there is a rule called as a pair sum rule which is useful. So we are going to study this. So let us start with an example. Let's say one of the signals is like this. So basically the signal is defined from -2 to +2, and in this range it increases linearly. This extra range that you see from -5 to -2 we have drawn for convenience, and note that it is not affecting the signal as such, because in this range all values are 0. This is 0. Similarly, beyond 2 all values are 0. So the real range for HT is from -2 to +2, and during this entire range it is described only by one equation. So therefore one endpoint of this range is -2 and the other endpoint is 2. So this you note down, range endpoints -2 and +2. These are the range endpoints for this signal. Next, you look at the second signal. Now in this case, basically the signal is defined between -1 and +1, during which it is constant. So the range endpoints for this are -1 and +1. Now how the pair sum is formed? So what you do is take -2, to that you add -1, so you'll get -3. Then -2 is also added to +1, so you'll get -1. Then you take the next number, add 2 to -1, that will give you 1, and finally add 2 to 1, that will give you 3. So when you do these additions, that sequence is called as the pairwise sum, and we write it like this. So remember, first was -2 plus -1, that was -3, etc. So we got these four values, -3, -1, 1 and 3. Now in this particular case, the way we added, it so happened that this was already arranged in the ascending order, and also the range endpoints are such that there are no duplicates in this. But in general, after you find the pairwise sum, you check whether there are any duplicates. For example, suppose this one is repeated again, then you drop all the duplicates. You retain only one value. So dropping all the duplicates and then arranging the sequence in the ascending order, you get the pairwise sum. In this particular case, it so happened that we did not have any duplicates, so we did not have to drop them. Okay, but what is the significance of this pairwise sum? Now that you have got this sequence, this tells us that when your time t, it lies between -3 and -1, there will be one expression for the product, and there will be definite limits for the integration when t lies between -3 and -1. So you'll have to solve this integral. Second is, when t lies between -1 and +1, you will get the second expression for the convolution, and finally when it lies between 1 and 3, you will get the third. So the advantage of the pair sum rule is it will straight away tell you how to select t, and it will also tell you how many number of expressions are required in order to describe the convolution completely. That is what it will tell you. Of course, the finding the expression for the product and finding the limits of integration, that you still have to do by graphical inspection. But at least one part of the problem has been solved. Alright, so when you first select t between -3 and -1, you find this particular expression. Write the expression for this, write the expression for this, take the product, and then by the inspection you will know the limits also. Okay, so whatever I have said is summarized here. Pairwise sum is given here. So 3 ranges in which the product expression and or limits can change. T between -3 and -1, when it is between -1 and +1, and when it is between 1 and 3. So as I said, you still have to find the expression for the product and limits of integration by the inspection of the graph. Okay. Now let me give you another example of pair sum, and then we'll return to the original example for actually solving the convolution. But let's take another example to illustrate how the pair sum is formed. Okay. So let's look at this. So again, this range from -3 to 0 is not strictly required to describe this function. So it is actually changing linearly from 0 to 1 with this slope. So that is, so for this expression, the range end points are 0 and 1. Then it remains constant from 1 to 3. So the range end points are 0, 1 and 3 for this. So let us write that 0, 1, 3. And as you can imagine, for xt the range end points will be -2 to +1, because this is, it remains constant in this range, -2 to +1. So now what you do, you start adding. So 0 plus -2, that will give you -2. 0 plus 1, that will give you 1. 1 plus -2 will give you -1. Then 1 plus 1 will give you 2. 3 minus 2 will give you 1. And 3 plus 1 will give you 4. So when you do all this addition, this is what you will get. -2, 1, -1, 2, 1 and 4. So in this case, you will find that this 1 is duplicated. So you drop one of them and then you arrange the sequence in the ascending order. So when you do that, discarding duplications and arranging in the ascending order, we'll get -2 to -1, -1 to 1, 1 to 2 and 2 to 4. This is what you will get. So this will tell you that you will have to select first t between -2 and -1, next between -1 and +1, next between 1 and 2, and finally between 2 and 4. So for this particular problem, it will be necessary for you to solve 4 integrals in order to get the expressions which describe the convolution completely. Alright, so we have seen a couple of examples in order to illustrate how to find the pair sum. Alright, having understood that, let us now return to the first problem and try to solve it completely. So first problem, remember, your h tau was linearly changing. So expression for h tau is simple. Slope is 1. Note this. From 0 to 2, the height is 2 itself. So 2 divided by 2, slope is 1, and it's passing through origin. So the expression for h tau is going to be tau itself. That will be the expression for h tau. As far as xt minus tau is concerned, it has a constant value 2. Now when t lies, so what did we say? We choose t between -3 and -1. So when you are sketching this, you should carefully sketch this so that you are able to find out what are the limits of integration properly. So basically what you have to do is to find what is the overlapping area. So you can see here, before tau equal to -2, h tau is 0. So even though xt minus tau has a finite value, the product is going to be 0. But starting from -2 up to tau equal to t plus 1, you will find that the product will be finite. Beyond t plus 1, what happens? h tau has a finite value, but then xt minus tau has 0. Therefore, your limits of integration will be minus 2 to t plus 1. And what is the expression for the product? This is constant at 2 and this is tau. So the expression for the product is 2 tau, that has to be integrated with respect to tau, and the limits will be from minus 2 to t plus 1. So for this range minus 3 to minus 1, the expression for the convolution can be found like this. Just now we have said that the expression for the product is 2 tau and the limits are from minus 2 to t plus 1. So the rest is straightforward. I am sure all of you will be able to do this integral and then put the limits. When you do that, you will get this expression. You can verify this, but you get this quadratic expression which will tell you that during minus 3 and minus 1, that means when t ranges between minus 3 and minus 1, the convolution is given by this quadratic equation, which tells you that the nature of the graph is parabola, and we'll see that once we have done all the calculations. All right. So remember the next range was from minus 1 to plus 1. So you have to locate t between minus 1 and plus 1. Now in this case you see that your limits of integration are going to be from t minus 1 to t plus 1. Okay, we have selected t here. So before t minus 1, this is 0. So even though this is finite, product is going to be 0. And after t plus 1, again this is 0. So which means that in this case, the limits of integration are going to be from t minus 1 to t plus 1. And the expression for the product, again as usual, tau multiplied by 2. So that will give you 2 tau. So in this case, your convolution expression will be integral 2 tau d tau, and limits are from t minus 1 to t plus 1. Again you can solve this and show that y is given by 4 times t. That means during this interval, when t varies from minus 1 to plus 1, the convolution is linearly proportional to time, and this is the actual expression. All right. Finally, we have to consider the last case when t lies between 1 and 3. So this is 1 and 3 and my t is somewhere here. So in this case now, you will find that beyond the value of 2, the first signal has a 0 value. Okay. So therefore beyond this we can neglect. Before this, before t minus 1, this signal is 0. That means this is your overlapping area, and the limits for integration will be from t minus 1 to 2. Those will be the limits for integration. And expression is still 2 multiplied by tau. So t minus 1 to 2, and this is what you will get. So you will get y equal to minus t squared plus 2t plus 3. Again a quadratic expression. So again you will get a parabola. Only curvature will be different, as we shall see. So now you can plot the convolution completely. So remember, from minus 3 to minus 1, this was given by t squared plus 2t minus 3. Now whenever you have a parabola, there is always a question whether it has a curvature like this or it has a curvature like this. So one way of finding this out would be to differentiate y with respect to time, so you will get a slope. And if you calculate the slope at the start point and at the end point, generally you will be able to find out whether the curvature is like this or opposite. In this particular case, you will find that when you substitute for t equal to minus 1 for the slope turns out to be 0. So if the slope has to be 0 at this point, clearly the curvature has to be like this. If it was like this, you won't get a 0 slope at this point. So that is the curvature. Then between minus 1 and plus 1, we know that y is equal to 4 times t. So it's a straight line with a positive slope, and that is your convolution. And finally, you got minus t squared plus 2t plus 3. And again, to find out whether the curvature is like this or curvature is like this, what you can do is find the slope at this point, and you will find that the slope turns out to be 0. So since it is 0, it could not be like this. You can't get a 0 slope with this curvature. So it has to be like this. So this tells you the application of pair sum rule in finding the convolution. So at least it makes the initial job easy. You know how many convolution expressions you have to find, and you know what are the ranges for t where the different expressions hold good. So that is the advantage of the pair sum rule. And that's all in this particular session.